In this lesson, we're going to learn to use dimensional analysis to complete calculations that involve length, area, and volume. Let's start by examining the relationship between them. Length is the distance between 2 points, and it's measured in meters or some fraction or multiple of meters. These are the length units that you should know because they're the most frequently used length units in science. They range from picometers, or 10 to the negative 12 meters, to kilometers, or 10 to the third meters. To give you an idea of the range of length units that we use in science, distance between atoms in a molecule is usually measured in picometers, and the distance between cities or even between planets is measured in kilometers. Now that we've covered distance units, let's look at area. The area of a surface is measured in square meters, or some multiple of meters that's squared. Here's a shrunken diagram that we'll use to represent a surface that has an area of 1 square meter. It isn't always convenient to measure area of a very small or very large surface in square meters, just like it isn't convenient to measure the distance between 2 atoms in a molecule or between 2 distant cities in meters. Here's how we convert an area in square meters to a more convenient unit of area. Let's say that we want to convert a square meter to square decimeters. Remember that there are 10 decimeters in a meter, but that's a unit of distance rather than area. There may be 10 decimeters in a meter, but a square meter has 2 dimensions. There are not 10 square decimeters in a square meter. A square meter is 10 decimeters long and 10 decimeters high. As you can see from the diagram, there are 100 square decimeters, not 10, in a square meter. Here's how you would represent this using the factor label method. When you convert between units that have more than one dimension, like square or cubic, you use the conversion factor for one dimension, and you raise the whole conversion factor, units and all, to the power of how many dimensions the unit that you want contains. Here, we squared the entire conversion factor from meters to decimeters to find the number of square decimeters that are in a square meter. To convert from a smaller unit to a larger unit, we would do the same thing. Each decimeter is 1/10 of a meter. That means that a square decimeter is 1/10 of a meter squared, or 1/100th of a square meter. Now we'll extend our math to calculating volume. The difference between area and volume is that volume has an extra dimension. Now we have length, height, and depth. Let's start with our square meter, or 100 square decimeters of area. We're going to add the extra dimension of depth. Each of our square decimeters is now a decimeter deep, so it has a volume of 1 square decimeter times 1 decimeter, or 1 cubic decimeter. We already calculated the area of a face of our cubic meter, 100 square decimeters. Multiply the area, 100 square decimeters, by the depth, 10 decimeters, to get the volume, 1,000 cubic decimeters. Converting between large and small volume units using only the distance units that make up the volume works the same way as with area. Take the conversion factor for distance, in this case 10 decimeters per meter, and raise it to the third power, or cubit, units and all. Volume is rarely measured using cubic decimeters because it's easier to define a liter as a cubic decimeter. Now that we've defined the liter, let's define another commonly used metric unit for volume, the milliliter. 1 milliliter is 1,000th of a liter. Let's call a liter a cubic decimeter again for a moment. To split the cubic decimeter into 1,000 smaller cubes, each cube would be 1/10 of a decimeter on a side. 1/10 of a decimeter is a centimeter. Each of the small cubes would be 1 centimeter long, 1 centimeter high, and 1 centimeter deep, or 1 cubic centimeter in volume. That proves that a milliliter is actually a cubic centimeter of volume. Let's show how to use the relationships between length, area, and volume to solve a problem. Assume that you want to collect rain in 200-liter rain barrels from the roof of a house with a footprint of 150 square meters, and you want to make sure that you have enough barrels for 5 centimeters of rainfall. How many barrels will you need? Our strategy here will be to find the volume of rain that represents 5 centimeters of depth over 150 square meters of area. Since the volume of our barrels is measured in liters, and a liter is the same as a cubic decimeter, the simplest approach to the problem would be to convert all of our dimensions to decimeters first. First, we'll convert the footprint of the house from square meters to square decimeters. There are 10 decimeters in a meter, so a square meter is 10 decimeters squared, or 100 square decimeters. Multiply our 150 square meters by 100 square decimeters per square meter, and we have an area of 1.50 times 10 to the fourth square decimeters. Now let's find the depth of rainwater in decimeters. There are 10 centimeters in a decimeter, so 5 centimeters is half of a decimeter. Area times depth is volume. Take our 1.50 times 10 to the fourth square decimeters of area and multiply it by our 0.5 decimeters of depth, and we have a volume of 7.50 times 10 to the third cubic decimeters, or liters. We aren't done yet. The question was, how many 200-liter rain barrels will we need? To get the answer, divide our 7.50 times 10 to the third liters of rain by 200 liters per barrel, and we get 37.5 barrels. We're going to round up to the next whole number to get a whole number of barrels to collect all of the water. We'll need 38 barrels to collect all of the water if 5 centimeters of rain falls on our house.